And everyone wants it, but no one quite ever does it, and it's quite hard to actually implement. So, these are things that people want, but they're not usually implemented. And probably the most important thing is that because of all of these languages and frameworks, we have N different libraries now that people are using to actually implement these best practices. So we have libraries that spit out stats. We have libraries that do retries and circuit breaking. And these libraries range in kind of sophistication from the PHP curl library, which isn't very sophisticated, to extremely sophisticated things like Finagle for Java, or the Netflix Hystrix libraries, which do incredibly sophisticated retries and circuit breaking and stats output and things like that. So the divergence of all of these things are quite large. So this is where we are right now, and this is what I think most people experience, is they experience this head-on fire pain. It's a pretty brutal situation. So this brings us to Envoy and kind of the service mesh, which people have obviously been talking about a lot lately. And the kind of 1 or 2 sentence plug for Envoy or for the service mesh is that we should make the network transparent to application developers. And we want our application developers to be as productive as they can be. We want them to focus on business logic. We don't want them to focus on service discovery and on rate limiting and on circuit breaking. We want them to write business logic. Coupled with that is the reality that in these distributed systems, things break. The network is fundamentally not reliable, right? I mean, you have things that are going to fall over. Actual hardware will break. You'll have obviously software, software failures. And when these things do break, the underlying network abstractions, they should make it so that operations engineers can figure out what's actually going on and then actually dig in there and hopefully either fix the problem or work around it. So this is what the service mesh looks like, and I'm going to do this super briefly because this has become so popular lately that I think most people in here probably have at least a rough idea of what this is. But the idea behind the service mesh concept is that we have a set of services up here, service A, B, C, and D. And we co-locate a proxy with that service. So in this case, we assume that local host networking is fundamentally not going to break, and that's an assumption that's probably okay. And so what happens is that a service, when it wants to talk to the network, it's going to send a request to its local proxy. The proxy will do all of the stuff that we've been talking about. So the proxy will do service discovery. It will go out and find other services. It'll output stats. It'll implement things like retries, rate limiting. It'll do advanced protocol work. The idea is that this proxy can take all this functionality that is quite complex to actually get right, and we can implement it in one place, and then we can make this functionality available to all of the services. So the flow ends up looking like service talks to proxy. Proxy does its fancy service discovery protocol stuff. It's going to load balance to a target service. It'll target that service. The request will be sent there to the other proxy. That proxy will make a nice pairing so that we can do tracing, we can do stats, we can do all types of good things. That proxy will deliver it to its local service, who will respond. The response will go back, and then that response will get delivered back to the application. The application only knows about localhost. So in this model, the network fundamentally has been abstracted from the application developer. The application developer says, I want to talk to service D from service B. The service mesh or the underlying abstraction makes that happen. And then the service developer can focus on their business logic. So from an Envoy perspective itself, Envoy is a self-contained server, so it is not a library. It is what we call an out-of-process architecture, so it's a server like HA proxy or like Nginx. And the benefit of that out-of-process architecture is that unlike a library, where you would have to take this library and implement it in every language that your org uses, which might be 10 different different languages. You can implement it once, and then instead of having to go and actually beg and plead your 100 or 200 or 300 service developers to upgrade that library and deploy, you can kind of have this this sidecar or this out-of-process proxy that you can deploy in parallel, and that leads to a lot of interesting possibilities. So Envoy is written in a modern C++ 11 code base. It is fundamentally an L3 or L4 proxy. So what that means is that from the kind of L7 app layer stuff to the L3, L4 TCP/IP stuff, Envoy is fundamentally a byte proxy. So what that means is that it can do protocols that we all know up at L7 like HTTP, but it can also do Redis. It can also do Mongo. We're talking about Kafka support now. So at its core, you have a lot of common functionality around service discovery, health checking, all of these things that can be done at that basic L3, L4 layer that are common to all different protocols. And then Envoy, just because the internet is composed of a lot of HTTP traffic and now gRPC traffic, Envoy has a huge amount of functionality at that layer. So we have a separate filter stack that allows you to do things like compression and rate limiting and buffering and all types of different things. Envoy was written as an H2 proxy first. At the time that Envoy came out, this was actually quite novel. The other proxies are now really only today catching up. And by H2 first, it means that Envoy is a transparent proxy in both directions. It can take H1 traffic, proxy it to H2, H2 back to H1. And this makes it usable as a gRPC proxy, as a bridge, actually taking legacy applications that don't work very well with gRPC. We've developed some mechanisms where you can take H1, send gRPC over it, transform it into H2, send it to a Go service, which doesn't actually know the difference, and then vice versa. Envoy does a large amount of service discovery as well as active and passive health checking. So active health checking is the ability to send a /health check request. Passive health checking is monitoring traffic that's kind of going along and looking for trends. So for example, if an upstream service returns, say, 3 500s in a row, Envoy would say, oh, this host is probably bad. Let's just boot it for now. Envoy does a whole amount of things around advanced load balancing. So again, you're going to have your retries, your circuit breakers, your timeouts, your rate limiting. It does request shadowing, et cetera. And most importantly, again, is really what we consider to be best-in-class observability. And that is, copious stats output, logging output, as well as tracing. And it's actually really exciting. In the last 6 months, there's been a huge amount of effort, kind of in the space. And we're seeing now people develop gRPC, APIs for actually spitting this data out. So it's not just textual anymore. We're actually developing APIs for this, which is super awesome. And the last thing that I'll mention is that Envoy is usable as an edge proxy. And what you'll see is that from an edge perspective, where obviously you're terminating TLS and you're doing probably more complicated path matching from a routing perspective, you'll see that edge proxies and service-to-service proxies, 95% of what they do is absolutely the same. They all do service discovery. They all do load balancing. They all do rate limiting and buffering and circuit breaking. And what we find is that historically, most organizations have run different proxy systems internal and then different proxy systems on the edge. So historically, they might run Nginx on the edge, and they might run HA proxy within. And that's fine. But from an operational perspective, if you can run one piece of software in your entire infrastructure, both at the edge and from a service-to-service perspective, it just makes operations that much easier, because now you obviously, again, you have consistent stats, logging, and tracing. So I've said this before, but you'll hear me say it again and again and again. It really comes down to observability. And we want application developers to be confident in the network. We want it to be abstract, but when things go wrong, we want to understand what's happening. And having that consistency across every hop in that network is super, super, super critical. And by having Envoy at every hop in that service mesh, we can pass things through a trace context, and we can actually link up our logs, we can link up our traces, and we can have consistent stats on both sides, and this becomes super powerful. So this is Lyft today, and you'll see that this is not too much different from what I showed before. But now we obviously have clients, we have the internet, we have our edge, our edge Envoy. We still have our monolith, which we are decomposing. I'm told that we are going to kill it in Q2. I'm a little skeptical, but we will see. So that's super exciting. We can kill the monolith in Q2. We have tons of services that are now written in Go. We have lots of services that are written in Python. We run Envoy on every service at Lyft. So it is impossible to run a service at Lyft now without running Envoy. And all communication happens via Envoy. So all service-to-service traffic is via Envoy. All communication to databases is via Envoy. And I haven't mentioned it too much, but this observability system, it goes beyond just service traffic. If we can get consistent observability for DynamoDB across every application language, or if we can get consistent observability for Mongo across every application language, that is extremely powerful. So what I'm going to do now is I'm going to take you through kind of the life of a Lyft developer, kind of focusing on what happens when an incident happens. And the goal of this is to show you some of the systems that we've built, mostly based on the service mesh architecture that allow Lyft application engineers to actually figure out what's going on. And one thing about Lyft is that Lyft to this day is a DevOps company, so we do not have SREs. We are about, I think the current numbers are, we're north of 500 developers, and we have an infrastructure org, I would say that's about 20% of the org. So we're about 80 to 100 people who work on infrastructure. And as we've grown as a company, trying to scale out this DevOps culture and kind of scale out this system, has been a very interesting learning exercise. And a lot of what we're building here is enabling people to actually figure that out. All right, so something breaks. Hopefully we get a page. Or maybe someone notices. And I think almost everyone these days is using PagerDuty. And what you'll end up seeing here is that, like in most companies, you're going to get a page. You're going to come here. You're going to get hopefully a link to some kind of runbook and a link to something that actually went wrong. And the first stop that most people at Lyft probably look at is we have dashboards that we generate for every different service at Lyft. And one of the things that we've been able to do because of Envoy, because of this consistency, is we can auto-generate dashboards for every service. So when you make a new service at Lyft, we automatically give you a dashboard that is populated with these top-line stats, of course, so things like response time and call volume and success rate. And of course, there's other things about the CPU and RAM and blah, 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 blah. And of course, we allow application developers to come in and add their own business logic kind of alarms and obviously graphs. But just having this consistency here where we can give every application service kind of that same top line, it already puts us in a situation where we can jump in and we can jump into any service and we know what that top row is actually going to look like because it's completely auto-generated. And on the left side, what you'll see is that we automatically give people link to the Envoy error logs. We give them links to live actual traces. So from an incident perspective, if a particular service is actually having trouble, we can get in here and we can see very consistent top-line stats, and then we can easily click and we can get access to other info. So from a logging perspective, Lyft uses Kibana as well as Elasticsearch for most of our logging. And what you'll see that I've highlighted here is that there is a request ID. And one of the things that Envoy does is it allows us to propagate a consistent ID across the mesh. So what we can do is that when a request enters the mesh, if there isn't an ID, we will make one. And then we will propagate that ID across the mesh. And that allows us to not only link up things from a logging perspective, but it allows us to actually do stable sampling. So by that, what Envoy will do is that based on that request ID, it'll suck out certain bytes from that ID. And if you're sampling at, say, 1% or 5%, or you're doing kind of consistent sampling with certain filters, Envoy will make sure that the same logs get sampled as that request flows through. And that is exponentially more powerful than doing something like 1% sampling, where you're going to get 1% of random requests, which is almost useless, right? I mean, it's not useless, but it's not very useful. Whereas if you can get stable sampling and you can look at what's going on as that request traverses all of your application stack and everything else, it makes it much more useful kind of from an incident investigation standpoint. With that request ID propagation, we also do tracing. And I think it's been interesting for me to see kind of the overall discussion these days about tracing. I think a lot of people look at tracing as something that is nice to have. I think where it's been falling short is that people find it extremely difficult to roll out tracing. And one of the things that you find is that unless you have good coverage for tracing, tracing is not very useful. Because if you send a request, but only 3 services have actually sent trace spans, that trace is not going to provide that much value. So people end up extracting a lot more value from traces when you get 100% coverage. But getting 100% coverage, but getting 100% coverage is extremely complicated because you have to go out and potentially, modify 10 different languages and 40 different applications or like 70 different services. So what we can do here is via Envoy and just a basic amount of request propagation from the application perspective is we can roll out tracing and have that be consistent across the entire mesh. And in fact, at Lyft, we rolled out tracing across our service architecture. And at that time, I think we had about 150 services. And overnight, we went from 0 tracing to 100% tracing. And that was because we were already doing log propagation. We already had that request ID or that data being passed between applications. So we coupled on that with the trace context. And just overnight like that, we went from 0 to 100% tracing. And what we find, again, from a trace perspective is that just having the basic data that Envoy can provide from a full 100% mesh coverage for tracing is often good enough to actually help really understand what's going on. But at Lyft, we also allow applications to inject their own application spans into the traces. So for advanced application developers who are doing complicated business logic, they can build on these traces and they can inject further spans. So we have, obviously at Lyft, we have very complex logic around generating ETAs and doing dispatch and stuff like that. So those services have actually invested quite a lot in sending additional spans around all the different units of work that actually happen to kind of produce that actual result. And but that's bonus, right? Because you get this 100% base, then you can allow people to tweak things on top, and it becomes super powerful. And you just couldn't do this without having this base functionality. The next dashboard that many Lyft developers look at, and this is probably my most favorite dashboard, is we call it our service-to-service dashboard. And in this dashboard, what we do is we actually have a drop-down box on the top left there. And this box is populated with every service at Lyft. And we allow the developer to specify the origin service and the destination service. And once they populate these two things from that dropdown, we're able to display both egress or sending information. And I'm not actually showing it here, but there's a bottom pane to this dashboard where we see incoming or ingress data. And you can immediately, from any hop in the system, you can get a really detailed view of what's going on. You can see, obviously, connections per second, requests per second. You can look at, the overall membership, health checking, service discovery, response time. And we obviously have things around circuit breaking and all types of different things. And this can be a very useful tool where when you know what's going on, or if you have a page between two services, but you want to try to figure out, is it a back-end service problem? Is it a networking problem? Is it across multiple AZs, or is it only in one? These are things that this dashboard can actually answer, and that's very powerful from a debugging perspective. This is our edge proxy system, our edge proxy dashboard. And what's been really interesting for me is, like I was saying before, about 5 years ago, the cloud load balancers, the observability output was relatively poor. Like, there was zero tracing in the Amazon load balancer product. You'd have to go into S3 to find your logs, and the output from the stats was quite bad. Now, the cloud vendors have made a lot of progress, but even today, I would say the observability output is still not great. And what you're seeing here is a portion of our dashboard from our edge Envoy system. And this allows us, from that front edge perspective, to see not only obviously connections per second on a per host basis, requests per second connections, but in that second portion of that row, what you're seeing there is you're seeing super detailed stats on a per backend cluster basis. So we're seeing requests per second per backend cluster. We're seeing upstream 500s on a per backend cluster basis. We're seeing P99 latencies on a per backend cluster basis. So just from an information density standpoint, coming here and looking at that edge and saying, what's going on? Like, is there a particular service that's actually having a problem? You can jump in here and kind of get that feeling relatively quickly, and then you can move between those other dashboards to actually dig in further. This is our Lyft global health dashboard, and what you're seeing here is actually, this is all envoys. So I think as of today at Lyft, I don't actually know the current number, but I think we probably run Envoy on somewhere between 10 to 20,000 nodes, depending on time of day. The mesh does anywhere from 5 to 7 million requests per second, depending on time of day. But this is a one-stop shop, which basically shows us in the overall mesh how many requests per second, what is the overall success rate, right? Like, what's the overall connections? And this is a super critical kind of, are we having serious problems dashboard, right? So it's like, this is a nice thing to just have a very high level view. And again, because the data is so consistent, we know that we have 100% fidelity here, which is quite nice. So, What you'll see is that, I have given this talk before, and I think people will look at everything that I just showed, and I think you'll say that that's pretty cool. I mean, it's quite nice that we have that from a 100% coverage perspective. But what we'll talk about now, and I think this is the most interesting part, is that I would argue that it's still too hard. And what you'll find, particularly from a DevOps perspective, where we don't have 100% professional full-time operations people, is that application developers, if you're asking them to go between all of those different dashboards and look at the logs and look at the traces, even if you have copious documentation and they're all quite smart people, it's not their full-time job. And what we found at Lyft is that even with this, what I would consider, I'm obviously biased, but what I would consider to be this incredible system, it is still too hard. Like, we still have too many questions from people where when an incident happens, even though all of the information is there, what I call the cognitive load is just still too high. Like, getting people to understand that, I'm gonna go in and look at these particular stats, or I'm gonna jump between the global dashboard and the service dashboard and the service dashboard, and I'm gonna look at the logs, it's still too hard. And what I would argue is that historically, we have been unable to make progress in this area, mostly because we spend so much engineering effort on trying to make everything look the same. Like we're trying to make all the application languages kind of do mostly the same thing, or we're trying to make them maybe output the same stats, or like make some tools that can do some basic stuff. And what I would argue is that the service mesh, it gives us this 100% coverage, or this base of data that in the future, and this is already starting to happen, will allow us to do some pretty incredible stuff. So what I'm gonna talk about now is some of the stuff that I think is probably, it's either being built now by companies like Lyft or by different startups, but in general, I think it's the direction that people are going to take this type of tooling. So what you'll see here is a system called Hystrix, and Hystrix was put out by Netflix, probably 5 or 6 years ago, or more maybe. And this is what I think is kind of the first great example of building custom UI to help people actually reduce cognitive load. So, most operations people, again, historically, they are used to looking at, things in Grafana with like X, Y charts that are very complicated, or they're, going to do queries in some complicated language. They're going to look at textual logs. And like I was saying before, is it doesn't matter how experienced you are, trying to piece together that data when things are on fire is quite complicated. So what they did with the Hystrix dashboard is, it was an investigation and saying, we have all this data, how can we actually, use some nice design, and how can we make it so that people can actually look at this data in a way that they can absorb it much faster. So kind of, you'll see up here is you'll see things where, that size of that circle is kind of roughly related to the throughput. You'll see that, there's obviously colors, so like green is good, yellow is okay, and like red's bad. And you'll see that it's just presenting, the most important data. And what I would argue is that this dashboard already, from a top-line investigation standpoint, it makes it so much easier to understand what's going on. Like instead of trying to parse those line graphs, you can quickly get a quick eye of like, this is the most important service, or this service is actually having issues. So this is, I think, just a great example of the type of UI that you can build when you build custom UI, to kind of give this data to people. So what we've been starting to look at Lyft, and there's other companies now that are kind of doing similar things, is if we assume that we have this amazing corpus of data, that we have this 100% coverage, what can we do with this? Like, how can we just re-envision how people interact with systems? So instead of jumping between the PagerDuty that then goes to the link to the thing to the log, and like everyone's confused all the time, we have all the data. Like, how can we just give people a UI that helps them solve the problem directly? So what I'm showing you here is a sketch of kind of what we're calling the service portal. And what you'll see on the service portal is on the left side, you have top-line metrics. So, from a Lyft perspective, this might be, rides, drop-offs, things like that. And then on the right side, we have timeline, right? So like from the perspective of operations, as much as people like to blame Amazon, the honest reality is that we break ourselves most of the time. So, I would say 999 times out of 1,000, it is our problem and not Amazon's. So, having a timeline of what happened from a deploy perspective, from people changing experiments or maybe changing some particular data, and actually being able to literally just line that up with what is going on that left side and have that happen in real time. I mean, this is already going to help you solve like most incidents, and most people don't have this. They get some page and they're doing what I showed you before. They're bouncing between logs and some dashboards and those types of things, when just a custom view that would show you, this service deployed or this experiment flipped and things started to tank it's very obvious, like all of the data is actually there. So you can wind up with this actual UI where, then you can have much nicer filtering for things that happened. You can have roles, so you can have, you can have operation roles where you log in and people who are operators can do things like roll back, but where other people can just view. So you can already get more powerful interactions that don't force you to always go to that CLI. And then next, what we can do, and we actually have this at Lyft now, and it's pretty amazing, is you can build, kind of additional UI. So this is you can basically get this view, which is a chord view of looking at all the services and just immediately looking at where's the problem. So in this view, again, you have, that width of that line is how much traffic. If it's green, it's okay. If it's yellow, right, it's maybe not so okay. If it's red, it's bad. But if you think about what I showed you before of like trying to look at that graph and saying, oh, like this one service, this line is up here for more 500s. Let me look at it, then like go to that service dashboard. That would have taken me, I would have to know what's going on, but I'd have to kind of spend probably 5 minutes doing that. This is an immediate link where this UI knows that this service is having a problem. It is visually incredibly obvious. I can click on that service, I can get information about it, I can page the person that's actually on call for that service, I can see what happened with that service, right? Like I can see if they just deployed or if something happened, like there was a scaling event. So just the information density here is vastly higher. And then you can also build a custom UI where once you click on that bad service, you can say, okay, here's the service, here's that Hystrix type view, but now I can actually look at all of the services that are calling me and all of the services that service is actually calling. So just by clicking through these three screens, this service portal entry, this kind of core diagram overview, and then the service detail, I can take all this information and I can kind of look at my error logs, I can look at what actually happened, I can allow people to actually go in and revert a deploy, I can page people, and I can have links here where I can click out and I can get to the detailed dashboard that I actually showed you before. So it's not like we're getting rid of that data. Like that data is super useful, but from a cognitive load perspective, we don't want our operations folks to actually have to start there because it's just too confusing. But we can kind of start with this, and then we can send them out to that additional, more detailed data. So what this gives us is that instead of, again, looking at the logs or looking at, kind of the XY graphs or the trace view, we can actually build custom UIs for people. Like we can build UIs that allow people to look at the most interesting information first and then drill down into more detailed information. And we can give them actions. So instead of just having a static trace view or a static view of like, oh, this is bad, oops, let me go find some run book and like figure out what to do, which is what happens, I can have buttons that actually allow me to roll back, or I can actually look at kind of what's going on behind the scenes, and using machine learning is I can actually do some pretty basic machine learning, and I can say, this host is not like the others. It's probably bad. Like, would you like to term it? And we can actually build UI where it might not be automatic, but when an operator comes to the page, if I can tell that operator that, with 85% confidence, I think this host is probably bad, would you like to term it? Yes or no. Most people will probably say yes. You just took probably what would have been a 10 to a 15-minute investigation of looking at all of those logs, all of those traces, doing the queries, maybe logging into a CLI or like going to the console and clicking kill, something that can probably be done in about 60 seconds. And from a business perspective, 15-minute to 1-minute remediation is quite powerful. And so we've got, all the stuff that we can do here from, again, this optimal visualization, the actions, we can do machine learning. And I think, possibly most importantly, like I was saying before, is that we can build, authentication and roles into the system. So we can have people that might not be service owners but want to understand what's going on with that service, but we shouldn't give them the ability to roll back. But we can also give these service owners the ability to do actual actions. So there's a lot of interesting custom stuff that we can actually do here. So, we've seen where we've obviously gone from this world where we've had this basic architecture. We went to a microservice architecture that was whole chaos. We have the service mesh architecture, which is a lot less chaos, but it's still chaos because it's computers. Now we'd like to take it to the next level, which is to say, to give people the ability to do not only custom visualization of what's going on, but we would like to be able to actually build tooling that can look at the data, right? We have this copious data coming out, and using, again, relatively basic machine learning algorithms, you can say, this is what's normal, this is not normal. Like, this is all relatively easily doable today, and we can start actually building tooling to allow people to say, this is not normal, would you like to fix this? That could be rolling back or booting this bad host. So from the Envoy perspective, what we're seeing now is that we kind of talk about Envoy as this, quote, universal data plane. And by that, I mean that Envoy provides an API. So Envoy is a data plane, which provides all of these nifty traffic functionalities. And we have an API that allows control planes, so the things that kind of configure Envoy to be built on top. And if I had come and given this talk about 6 or 9 months ago, we would have been talking only about Istio. But in the last year, there's now probably 6 or 7 or 8 different startups and open source things and more that are being built on top of Envoy, which is pretty amazing. And they're doing that because we have this API which allows these control planes to kind of configure Envoy in any way that actually makes sense. And the flip side of that is via all of the data that's coming out. So we have APIs coming into Envoy, and then coming out of Envoy is basically this this actual stream of data. And that's going to be stats, logging, as well as tracing. And you can kind of imagine this situation where we have obviously control coming in, data coming back, and it becomes very doable to actually build this, and that's kind of what we're working on right now at Lyft. So this system allows us again to build things like Istio and other comparable systems, and then it also enables us to build, I would say, parallel management systems that in the future might look at Envoy data, for example, and analyze it for DOS attacks, right? Like, you can easily imagine that if we have data flowing out of Envoy, even if it's sampled, it becomes relatively easy to actually say, this is normal data, this is a DOS attack, or this is some type of security thing. And in parallel, we can build custom UI where now that we're not having to sit there and focus and fight on the 10 different libraries and all these different things, and we have this basic network abstraction, which is pumping all this data out, we can focus our energy now on building this kind of pretty incredible tooling on top. So that is what is happening, and it's super, super exciting. So that is my talk. I thank you very much. And I would say in general, the growth around Envoy in the past, we open sourced at the end of, I don't remember now, it's like a blank, it's like the end of 2016. And in the last year and a half or so, the growth has been just absolutely stupendous, just from the number of companies that have been interested, the number of things that are being built on top. And I am super excited to kind of help not only bring this service mesh architecture to different companies, but per what we talked about here, I think that we're just scratching the surface of some like really incredible things that we can end up building. So there's the website, my super obvious plug that Lyft is hiring, and thank you. And I'm happy to take questions.
So we are videotaping, so please, if you have a question, use a microphone. If anybody, put up your hand and I'll bring a microphone to you.
Mark, back.
Hey, yeah, I'd just like to rewind to a bit earlier when you were talking about how you went from 0 to 100% in tracing. So you need to tie the incoming request with the outgoing request. Like, Envoy can't magically do that. So like we're using Istio, just very early stages here at Hootsuite. Now you have to propagate the headers of trace IDs that come in. So you're not creating spans, but you still need to stitch it together. So how did you go from 0 to 100?
That is a fantastic question. Yeah, when people come up and talk about service mesh, we talk about this kind of magic thing where you roll it out and it just magically is totally amazing and you don't have to do anything. That's not true. The one thing that you have to do is context propagation. And what we did at Lyft, partly through foresight, is we knew that we were going to have to do this. And you have to do context propagation for two things, obviously. One for tracing, but also for logging. So I talked before about how if you actually want to do stable logging and stable log sampling, you have to pass this ID across. So we had been doing stable log sampling at Lyft for quite some time, like probably 1 year or 9 months before we actually did tracing. And we kind of future-proofed that system where the header that we were going to use to actually propagate things across, we kind of built the code such that we could basically do that. Now the question remains, how did we do that? And what you'll find, and this is an area that I think the industry is doing a fairly poor job of right now, but it's getting better, is the entire kind of realm of context propagation is in not very good shape. From a developer perspective, it's relatively poorly understood. The ability to kind of do this in libraries that everyone uses are not really available, and it's really easy in some languages and it's really hard in other languages. So for example, in languages like Python, where if you're using G-event and you have like G-event or like thread local storage, it's super easy. Or like really in any language where you have thread local storage, it's super easy. In a language like Go, which has no thread local storage, it's actually quite hard. So you end up having to propagate this context thing like through absolutely every single function. So at Lyft, we were primarily using PHP, Go, and Python, and we knew that we had to do this. So at the time where we were rolling out Envoy, we still only had probably 30 to 70 to maybe like 100 services. So at that time, it was easy to actually go in and just kind of make it happen. And like I said, in Python, it's super easy. PHP is trivial because it's one process per thing. And in Go, it was more work. And what that means at Lyft, I didn't show it in this presentation, but at Lyft we have, in each language, we have a kind of a thin client, which we call Envoy client. And application developers, when they call other services, they use this thin client. And instead of like knowing that Envoy is running on localhost, port, whatever, they instantiate a copy of Envoy client. They say, I'm going to talk to the user service. I might set some options. So we actually use this client to guide developers in terms of good practices, in terms of setting timeouts and retry policies and stuff like that. And that client also does context propagation. And some people will say, well, oh well, you told me this is magic, and now I have to write this code, right? So Envoy client is like 200 lines of code, and Envoy is like 100,000 lines of code. So I mean, it's like it's not really comparable, but it is true that you will have to write some code. Now, my hope is that there's new libraries that are coming out. So there's Open Census from Google, and my hope, along with Open Census and Open Tracing, is that these might become industry standard libraries that kind of handle this context propagation for people, so that it's not like an every company situation where every company has to build this Envoy client type situation and figure out context propagation. So that was a very long answer to your question, but I would say that we did it through foresight. Every company has to have that foresight That is the most critical thing, because it's the hardest to backfill, because that's the thing that you have to have every service do, and if the service doesn't do it, it is totally broken. And so that's the thing that I would start on now. It's like, even if you're not going to roll out a service mesh for 2 years, I would say start the context propagation process right now.
Oops.
Sorry, what?
Yeah, we didn't have that foresight, but we're rolling out rolling out gRPC, and so yeah, we're kind of putting that in now.
Yeah.
As that, it's a very other context propagation heavy type of framework. So yeah.
So like, do you guys care about context propagation to like external services? Like because like when you say Envoy client, that in wrapper, that's presumably for internal services only, right?
Yep. So we care. Like, I would love to have traces that span. Right now, again, it's basically not possible. I mean, it's like there's just I could talk at length about tracing. I'm not going to do it on camera, so we can do it probably after maybe. But there are a lot of competing interests in tracing, and you obviously, like, you can pick your own solution for your internal system, of course, but then when you want to bridge what would arguably be the most powerful thing, which is to be able to look at your traces and then also look at it with like DynamoDB and like other services, that would be absolutely incredible. The problem is that it's a really hard problem, because like not only are these systems using different tracing systems, but there's information that would have to be shared across trust boundaries. Like, it's a super hard problem. So I would say that every cloud provider wants this to happen. Like, it is the grand vision that I will be able to do traces, and I'll be able to bridge those traces with my Spanner or my Bigtable or my DynamoDB. But right now, you basically have to be within one vendor ecosystem to have that traces work. So like, if you're in Amazon and you use like Fargate or EKS and like DynamoDB and X-Ray, like, it'll all just work. If you don't, it doesn't work. I mean, that's kind of where it's at right now.
Hey, Matt. You mentioned earlier talking about sample rates when you start the trace, when a new request comes into the system, and that Envoy is doing something a little more clever than just random sampling. But I kind of missed what the clever bit is there. Can you talk a little more about how that's better?
Sure. Yeah. So what we do is that we basically have this UUID, that either comes into Envoy, or if it's absent, Envoy basically makes it. And what we'll do in Envoy is, we can actually set certain bits of that UUID. So, for example, if you force a log, or you force a trace somehow, and you can do that in Envoy via certain filter matching, we will actually mangle that UUID and set a certain bit, for example, and then when that UUID gets passed around, it will circumvent all of the different sampling. So we can do interesting things where it's not just a basic UUID, like it's a UUID where we control certain bits in it, and based on those bits, we can either use that kind of to do stable sampling. So you got your 16 bytes of that UUID. We can look at 4 bytes of it, and we can kind of use that as our random number, so that when we're doing kind of sampling calculations, we can base raw sampling based on that quote random number. But then let's say that something happens and something is basically interesting, or a developer says, I'm going to make a request, and we have a header in Envoy, like the X Envoy force trace header. That header, what it will do is it'll mangle a bit in that UUID, and then every subsequent Envoy will log. So there's some cool things that you can end up doing there.
Okay, I think I just understood an important distinction. There's always a UUID, even if it's not tracing. That's what you're saying.
Yep. Mm-hmm.
I understand.
Yep.
Thank you.
Yep.
Any more questions?
Grab another. So you're making, with a proxy, some generic rules, for instance, for circuit breaking and retries. So if you get say a 503 or 504, it would be probably an appropriate thing to do a automatic retry on that, for instance. Now, is there what are your thoughts on having the application be able to override the service mesh defaults? So I might be doing a request, it's a post, now it's not guaranteed by idempotent, but I know it is, so I actually want it to retry. Possibly some other settings with the mesh, like is there any kind of ideas on how you would have the application communicate directly with the sidecar to override?
Yeah, I mean, we actually we do that right now. So the way all of these settings work within Envoy is you can configure them two ways. You can set them in the actual configuration. So based on routes, you can set timeouts or different types of circuit breaking policies, retry policies. But almost every setting in Envoy can also be controlled by headers. So what we allow the application to do, and in fact at Lyft, this is what we do with our Envoy client, is with certain guardrails, we will let application developers override those policies. So if they know that they want a particular timeout, probably shorter, possibly, we will basically let them do that. And through those headers, you can configure most different things.
Hello. At Lyft, this is more of a question to figure out like how you guys are you running Envoy across the different environments that you have at Lyft? So like if you have a dev environment, staging, and production, and do they have the same level of observability? So as a developer, if I'm like, let's say, modifying my service on localhost, I want to be able to deploy with confidence knowing that, this thin little client, Envoy client, how are services stubbed out? How do you ensure the contract between services? Do you maintain different SDKs for the Python and Go services that you have? Or are you using an IDL-based solution like protobufs? If you can elaborate a bit more about that.
Sure, yeah. I could probably give an entire talk on the horrors of doing development because I haven't seen any company where like development of microservices is not a total shit show. And so I can talk about what we do at Lyft, and I can talk a little bit about kind of why it's good and also why it's not so good. So at Lyft, yes. So in general, right now, what we do is we have production environment, we have staging environment, and then we have dev. Dev runs on the laptop roughly, or it can also run kind of up in the cloud in what we call a one box. And in general, application development looks the same no matter where you're running, and that's actually one of the beautiful things about this system. So you write your code, but at most companies, you have config files that are filled with basically like if staging do this, if dev do this, if prod do this. When we switched to Envoy, all of that was gone because now you use Envoy client. You say you want to talk to user service, and that's it, right? And so like if you're in staging, you get routed to staging. If you're in production, you get routed to prod. Dev is a more interesting beast, and I say that because like most companies, Lyft historically, we have a tool called DevBox. It runs on your laptop, and it uses Docker and containers, and we have all our services containerized, and that was really amazing when Lyft had like 30 services. It's not so good anymore. So in the current world at Lyft, I'm going to be totally honest in saying that the development situation, it looks just like staging and prod, meaning the config files are the same and like the code just roughly works. The honest reality, though, is that we are struggling, like most companies, with how do we get people off of their laptops? Or like how do we let them develop some services on the laptop, but then some of them are stubbed or they're partially in the cloud and partially on their laptop. So we're actually undertaking a tremendous effort right now to kind of do our next version of this system, and this is kind of go along with so Lyft is of the era where we're all on virtual machines. We are not yet using Kubernetes. We're just putting it into production now. So we're kind of beginning our Kubernetes migration, and I think along with our Kubernetes migration, we're really starting to think about what does dev look like, and I think dev in the future is going to be much more of a combination of some things running on your laptop and some things running up in the cloud. And the one thing that I will say is that kind of went with the service mesh in place, doing that because of the abstraction. The same abstraction applies in dev, and it's super nice. So it's like if I'm used to doing something in dev and I'm running my 10 containers on my laptop, if we do some changes to the developer experience and now I run 8 of them in the cloud, the developer doesn't need to know that, right? Because Envoy basically just does all that routing. I'm not going to claim to you that that's working right now because it's not. But that's the goal, and I think for us, it's again like most companies. We have Docker container images that like somehow end up being like 2 gigabytes. Like, how did that happen? I think we're struggling to figure out how do we get dev sane again. But yes, like it theoretically should look the same.
Thank you.
Hi, Matt. Great talk, thanks. Looking into cloud specific services or cloud managed services, obviously visibility into those services is limited, and for most of them, it's a black box. How well Envoy can be integrated into those services from observability standpoint, especially in comparison between different cloud providers, GCP, Azure, and AWS.
Sorry, so from cloud services, are you talking about like hosted Kubernetes or like what types of things?
It's both hosted Kubernetes and services like RDS, S3 storages, etc.
Sure. I can't speak as much for things like RDS or stuff like that. I do think that what we're going to see happening increasingly this year, I think by the end of 2018, we're going to see a lot of hosted Envoy products. I don't know exactly what that will look like. I think what that is going to look like at a very high level is that as we see this move towards hosted Kubernetes and hosted container systems, so like things that are doing, functional systems like Fargate or Lambda or stuff like that, all of these systems have the same problems. Like you have to do routing, you have to do retries, right? And what I think most of the cloud vendors are realizing right now is that, like all of these people have to do these things. Are we going to make them all like figure out how to pod inject like Envoy or HA proxy or like some other solution? So I think the cloud providers are, trying to figure out, there's clearly customer demand for kind of having this functionality built in. We'd like the customer not to have to run it themselves. So I do think that all the cloud providers at some point are going to offer some type of service mesh product. Like I can't claim that it's going to be Envoy. Like it might be their own thing. It might be some other solution. But I do think that it's kind of a no-brainer that this type of functionality will be given to customers. What I would say is that I think it's a little bit of a proxy arms race right now, and by that I mean we have a lot of development going into a lot of different systems, and I think what will happen is that I do think that there is kind of going to be winners and probably losers here, and the reason for that is that once one or more cloud providers or big organizations kind of pick this system that they're going to end up building, it becomes a competitive disadvantage for other organizations to invest so much effort into making something similar. So I'm of the opinion, whether it's Envoy or something else, that I actually think that all of the data plane stuff is going to become totally commodity. Like I really do not think that building a business on top of just Envoy or like just that data plane piece is ever really going to fly, because it's going to become table stakes for all of these systems like EKS and Fargate and Google's Kubernetes system. Where I think that a lot of the interesting stuff is going to be is actually this talk. Like I think people are going to build control systems on top. So like you can imagine where if you're on Amazon or you're on Google or you're on Azure, you can imagine that you can just buy containers, you can buy Envoy or something else that kind of gets launched. But you can also imagine that there's a marketplace which allows people to bring in control systems that do really interesting things, like whether that's observability or DOS analysis or like security analysis. So I think that the data plane stuff is just going to become free. Like it's going to just be built in some fashion. And then I think that there's going to be a lot of people that are jockeying to kind of build this type of nice like analysis and visualization software on top. Did that answer your question?
You did. Thank you.
Okay, sure.
I have a related question. How do you see the coexistence of different control planes? Let's say you've got Ambassador, you've got Glue, you've got Istio. How do these things work together, or do I have to pick one?
That's a tough one, and I probably shouldn't answer that. Right now, like we're kind of in this. We went through in the industry probably 10 or 15 years where things in this space were fairly stagnant, right? It's like, I mean, not that development wasn't happening, but it's like people basically use Nginx, like they basically use proxy. They would build on top of various load balancers. And then I think with the kind of the increase adoption of microservice architectures, people are just having these networking problems. So the problem is coming to the forefront. So now we're kind of in this massive development period where like there's a lot of proxies, there's a lot of control systems being built on top. Now, do I think that it is like a winner-take-all system? No, I mean, it's like we have lots of cases of like, different systems that coexist and people are super happy with them. So I honestly have no idea how it's going to play out. What I do know, though, is that the ecosystem growing around Envoy, this is kind of that snowballing effect that I was talking about before. Is that as more people hop onto the platform, it just gets more robust. Like the APIs get more powerful. Like it just gets more stable. So what I do know is that it will make Envoy better. I don't know what will end up happening in the control plane space.
More questions? Good. Oh, Mo.
Going back to your your dev environment, the question there, like, what are some of the ideas you have for having like the laptop and the cloud kind of dev environment with Envoy involved?
Yeah, so we're currently looking at certain things right now. So so for example, right now, right, like we have a relatively nice system for staging and for production in terms of how people roll out route changes and kind of do various things. And the situation for development right now is basically like, if you want to test an Envoy configuration change, here is a markdown page which has 11 different steps, and like if you do them just right, like it will happen. And those steps are fine, right? But it is more complicated than we would actually like it to be. So I think for the future, there's a couple of different things. Like there's to fully converge what the experience looks like across development, staging, and production. So in production, if I'm used to going and modifying some file or using some UI to actually tweak different settings, I want that UI to work in dev also. Like the development experience should be identical. I think what will likely happen moving forward is we will be investing probably in mock services. So that's probably first thing, is like making it so that you don't have to stand up the entire service. So as we've moved at Lyft, we're increasingly taking on gRPC. So historically, Lyft is a REST-based architecture. A lot of new services are using kind of strongly typed IDLs. So I think it would become easier to start doing certain types of mocking there. And I also think that we're going to have to start investigating what it looks like to do both laptop and cloud dev. So I think that's where probably a lot of the thinking will actually happen, where whether it's a full offload situation where like literally I am developing in a Kubernetes cluster in the cloud. I don't know how it works. And we're doing stuff where like my IDE is actually hooked up to the cloud, or it's doing rsync or like something like that. Like that's kind of one camp of thought. And then the other camp of thought is, well, we can allow people to run a service or two on their local laptop, but then we'll actually be sending traffic back and forth from cloud back to laptop. And we did some experiments there, and at least when we first did them, we actually ran into problems because services were doing so many calls that we're expecting them to be like 1 millisecond response time, that now like you're running a test and it takes like 10 minutes because it's like going back and forth with like 200 millisecond latency. So the irony there is that, you know, sometimes in fixing some of those things to make dev work better, you can make your services actually work better. But so I think the main ideas there are to unify what it means to do kind of development and configuration of the mesh, whether you're in dev, staging, or production, but then to figure out the right flow of either a hybrid model of running some services locally attached to a cloud cluster, or development takes place in the cloud only, but there's enough shim and like enough fakery there where like I can use my IDE and I can like compile or run my scripts, but it just happens there. Yeah.
This is like a very, very, very similar situation, like extremely similar.
Yeah.
Thank you.
I think almost every company is in this situation, and if there was an easy way to solve this, you would be very rich, but it's an extremely hard problem.
Wonderful. Any more questions? One last question. Okay. Well, Kush has got one more question.
Yeah, so follow up. You mentioned you guys are starting to write gRPC services. I'm just wondering how far along you are on that. Like, how many services you have talking to each other in gRPC?
I don't know the actual number. We have quite a few now. So what we've done at Lyft is we're moving most of our kind of tier 0 or like data-oriented services over to Go. So we have PHP, Python, now, you know, at least some of the more critical services are kind of moving over to Go. And most of those services are all using gRPC. And I'm hoping we're going to open source a bunch of stuff in terms of what we've been doing this year. I can't promise that, but it is a pretty gnarly problem in terms of like how you manage your IDLs and how you get them compiled and like versioned and send them out and actually use them. The other problem that we have had at Lyft is that historically gRPC and Python not so good, and particularly gRPC and gEvent Python really not so good. So we've had quite a lot of problems of kind of trying to get Python using gRPC. And in fact, in Envoy, we did this thing, which I think is pretty cool, but it's actually a huge hack, where we basically have Python talk to Envoy over HTTP 1.1 and send gRPC. Envoy upgrades it to H2 and then sends it, and then actually downgrades it back to HTTP 1 because the gRPC libraries just like don't work. So now, that's being fixed, but like this is as of 2 years ago, it was just like, it didn't work. So we had to do some pretty creative things to kind of make that happen. I would say that developers really like it. Like, it's really nice when they suddenly realize, wow, all of those errors because I casted this string to like a double and it broke. Like, like pretty obvious stuff, but I think developers generally are quite happy with it. I think our uptake of gRPC is going to greatly increase this year. We're bringing gRPC out to the client, so we'll be doing it on both iOS as well as Android. And I have a feeling that over time we will increasingly move almost all things. But the way that we've seen most migrations go, or I think the way that has been most effective that I've seen service owners do, is they continue to serve their REST API, and then they basically just tell people we're no longer adding any features to this API. So like, if you want new features in my service, you have to use this new API. And they just continue to serve that REST API at the frozen version. And if people want new features, they kind of move to the new kind of IDL-based version. But there's lots of interesting stuff there. There's people on my team who kind of work on this more than I, and they do give talks. So maybe sometime one of them can come up here and give an entire talk on gRPC.
I have another question about tracing. So I've heard of people treating the distributed tracing almost like a profiler and going further down to what's happening in the call stack of your service. So like doing timings of disk seeks, access of whatever. So creating subspans of all the actions that are going to be happening in your service. Do you think it's appropriate to take all that data and sort of push that back out onto the network and conflate your networking profiling and your tracing mixed in with like that to have like a super detailed trace of an entire request graph?
You know, I can't say that I have a very strong opinion on that. What I would say is I think tracing is very useful. I think where tracing falls short, in my opinion, is that you need a very good UI to make sense of any type of trace. And I think what I've seen is that when people have these traces that are like have like 50,000 spans in them, trying to figure out what's actually going on there is like almost impossible. So what we've seen at Lyft is I can't say that we've had a lot of desire at Lyft to like, you know, instrument every tiny small thing. So I mean, it probably would be useful in certain cases, but I guess my advice would be start with getting like very granular coverage, but 100% coverage, right? And then I think what you'll find is that you're going to just look at these traces that may not be very long, but they're full end-to-end coverage, and then there'll be really obvious places where you might say, I would like more kind of deeper spans. So I guess my advice is like, I would not personally go around and like get every little span from every service, just because I think it would be information overload and probably not very useful and also end up costing a lot. I would recommend kind of going with the more kind of the coarser 100% coverage view and then figuring out kind of where it's actually useful.
That looks like it. Okay, so now we're going to have a chance to socialize and maybe some one-on-one questions. But before that, let's thank Matt for coming up from Seattle today and giving a great talk.